What's for dinner? Day 3. So first I asked everybody to take a look at the questions on the board, and then I'll move myself. No, I'm just going to be in the way all the time, aren't I? Let's see if I can move it over here. Sorry. So we took a look and looked at these different organisms here and created a food chain on our whiteboards in the classroom. And then we labeled each organism with its niche or role. So here's what we ended up talking about. We said we were going to learn more about energy pyramids using videos and doing some practice and thinking outside the box so that we can understand how organisms in a community interact to obtain the matter and energy that they need to survive. So if we're thinking about the organisms that we had right at the beginning of class, if we make a food chain, we always start with our producer first. So we have a producer, that's the grasses. And the energy from the producer goes to these hares, these rabbits. Those are the primary consumers. Producer, primary consumer. He's the primary thing to eat the producer. After that, we have a secondary consumer. This snake is going to eat the rabbits. And after the secondary consumer, we have this eagle. That's tertiary consumer. So producer produces energy using the sun and doing photosynthesis. Primary consumer eats producer, secondary consumer eats primary consumer, and tertiary consumer eats secondary consumer. But we also have decomposers. We don't want to forget our decomposers because the decomposers break down any dead organisms and return their nutrients back into the environment. And that's important because number 1, we get rid of dead organisms that we don't want to have just lying around. And number 2, we want to use those nutrients again because everything is recycled in nature, sort of. Okay, so looking at this image of an ecosystem. This is a food web, obviously. But there is something different about this food web than we have seen in most of the food webs so far. And the thing that we are seeing now, we are seeing these decomposers down here. So we haven't explicitly talked about what the decomposers are and what they are doing to the dead organisms, but we'll learn a little bit more about that today. So I'm going to back up just to say that we have bacteria, fungi, which would be mushrooms and things, and other decomposers like worms that are in our ecosystems that help break down anything that has died. When they break down the things that have died, they're going to break them into their simple chemical compounds like phosphates and nitrates. So realize phosphates comes from the word phosphorus. So that's a form of phosphorus. Nitrates comes from nitrogen, which we looked at in our own ecosystems, but we actually measured nitrites. So that's different. All right, so for today's lesson, what am I learning and why? I'm going to learn more about interactions in ecosystems in Yellowstone so that I can understand the flow of energy and I can understand that animals interact so that they can obtain the energy they need to sustain their life processes. All right, so I asked people to think about positive things that have happened since we've put wolves back into Yellowstone. And some of the positive things that have happened are we have had some environmental and conservationist groups working together with cattle ranchers to try to make sure that the wolves do have a safe place to be. So originally those groups and organizations might not have realized that they had a common goal. We also know that now we have a lot more wolves in Yellowstone, and they had been practically extinct before, but after the reintroduction, we have now increased the population of wolves in Yellowstone. And also, we know that we have kind of realigned the balance of the populations of elk and deer and other smaller predators. And so we have done positive things to the ecosystem within Yellowstone because of adding wolves. All right, and so in your What's for Dinner packets, you can answer some information about whether you think that wolves belong in Yellowstone Park. We also know other things that were positive effects from adding those wolves in. They may increase tourism because tourists may be interested in seeing the wolves in the park. It's just another idea. All right. So we're going to think about important information from our last class. This, of course, is a food chain right here. We talked about a lot of different vocabulary. So if you'll go into Schoology folder for What's for Dinner Day 3, there is a review slide deck, and you can use that review slide deck to help answer some questions in your packet. You should pause the video, because I'm not going to run it for 10 minutes. Pause the video while you look at those review slides. All right, and so if we're thinking about the review slides, which organisms are needed for the survival of all others in this food web? We know that the marsh grass is extremely important and the cattail is extremely important. Those producers are generally the things that we think of as being the most important. So we've got our marsh grass and our cattail. Producers are extremely important. Where can the frogs get their energy from in this ecosystem? Here's my frog, and remember the arrow shows the direction of the flow of energy. So this frog is getting energy from this butterfly, also from this grasshopper, because the energy from the grasshopper goes to the frog. Also this dragonfly, even though it's a little bit higher than the frog visually, you can see that the arrow shows that the energy goes from the dragonfly to the frog. So we've got 3 different places that frog is getting its energy. All right, 2 possible things that could happen if something killed off most of the finch population. Here's our finch population. So when we're looking at this food web, we want to realize that if I lose my finches here, my buzzards are going to have fewer things to eat, right? The buzzards will still have snakes and mice and rabbits. They'll still be having some things to eat, but they just won't have any finches. So they might eat more of the snakes and more of the mice and more of the rabbits. If they're eating more of the rabbits, the fox has a little bit less to eat, right? If they're eating more of the mice, the fox has a little less to eat. The fox also has less to eat because the finches are gone or mostly gone. Another thing that can happen is if the finches are gone, look at what the finch was getting energy from. Berries, right? So maybe now there are more berries because there are fewer finches. If there are more berries, there might be more butterflies. There might be more grasshoppers. If there are more butterflies and more grasshoppers, we might have more frogs. And if there are more frogs, we might end up with more snakes. The buzzard eats the snakes. And so, by losing finches, maybe it's not such a bad thing because the buzzard still can eat lots of snakes. It's hard to know because anytime you mess with the food web, you just have many, many changes. Many things are going to be affected. All right. What are the secondary consumers? Well, remember we first have producers on our bottom level. This word phytoplankton. Plankton are little creatures that are very small that float around in the ocean water oftentimes. And so phyto is a prefix that has to do with plants. You can also have zooplankton, Z-O-O plankton. And so those would be animal planktons. These are plant planktons. And we know plants can do photosynthesis. So our producers in this exact this exact energy pyramid are going to be those phytoplankton. Producers, phytoplankton right here. Crustaceans are eating the phytoplankton. So the crustaceans are the primary consumers. Herring would be eating the crustaceans, primary to secondary consumer right there. All right, and so which level on an energy pyramid has the greatest amount of energy? That is always going to be our producers. We have the greatest amount of energy here, And then every time we move up a level, we are losing most of our energy. We're only going to send 10% of the energy up to the next level. So producers are going to have the greatest amount of energy. We lose 90% of our energy. Then we lose 90% of our energy. Then we lose 90% of our energy. There's very much smaller amount of energy on our primary, secondary, tertiary, on our tertiary consumer level. All right, so we have a 10% rule. Barely any, right? Such a small amount of energy is passed. So from producers to primary consumers, we only send 10% of the energy. Primary to secondary, we only send up 10% of the energy. And again, 10% of the energy goes to the tertiary consumers. Okay, these are called trophic levels. So think about autotroph and heterotroph. If you want to think about connecting your words, trophic level. So when we look at a different energy pyramid or any energy pyramid, we know 10% of the energy is moving from one trophic level to another. What happens to the other 90%? The other 90% of the energy is lost as heat. All right, so in class we did a pair deck, and then we came back after our pair deck, and I had everybody look at what's for dinner day 3. There's an ecosystem/energy pyramid independent work in your Schoology folder. So please take a look at that. I gave 13 minutes, and then I probably gave an extra 2 or 3 minutes. So you'll pause the video, work on this ecosystem energy pyramid independent work. You can use your packet, and if you pause the video, you can come back when you have finished that. Okay, and so we have an exit ticket for what's for dinner day 3. Of course, you get 2 attempts, and if you get anything wrong after your first attempt, check it over, check your notes and see if you can figure out what you got wrong, and try again.